In this live stream, we'll go over how to make an Asteroids game using p5.js, or actually p5.play. So quickly, what is p5.play? As you can see here, this is the homepage for it. It's an extension of p5.js, meaning an addition, and it helps with creating games. And so it provides things like sprite classes, other supports like basic collision detection, groups, keyboard interactions, etc. And so to use this, you'll need both p5.js library as well as the p5.play library as well. And so the Asteroids game is something that looks like here on the homepage background, and there is an examples which we will be following. Cool. So in examples, let's take a look. This is the game that we will be basing it off of. As you can see, right now you can rotate. You can rotate around. The control keys are arrow keys, and then you can press X to shoot. However, you can't move forward right now. And so that's a bug. And then when you shoot, the asteroids do get smaller, but there are no particle effects. And as you can see, the asteroids can hit the player or the ship, but the player does not die or does not get destroyed. So these are all bugs, and we want to take this example, build upon it, and make it better. So let's do that. So the code, the source code, as you can see, is below, and we will kind of take inspiration from it and improve upon it. So I have a HTML, CSS, JavaScript repl.it created. Let me just first make this full screen so you can take a look. This is just the basic template. And first of all, let me close this on the left. We don't need it. And let me align it so you can see. The left side is repl.it, the right side is the p5.play example source code. And since we're here, actually, let me full screen this again. Let me open this up one more time. Well, let me just refresh this one time. Well, it's refreshing. Let me just reopen this again. Yeah, and let me click this so that it opens in a new tab. Cool, so right now it's blank, which is correct. And now close this back up again. Excellent, and then there we go. So the first thing is in order for this to work, I will need to load both the p5.play and the p5.js libraries. So to do that, we can actually grab the libraries. They're both loaded on this page. We click inspect, and it will show you the elements pane below. If we go to sources, we can actually see, bring this down a bit, that we have the p5.play.js library under p5.play lib p5.play.js. And the other library that it depends upon, which is the p5.js library, you actually find it under examples lib p5.js. Now, this can be a hassle if the directory structure is a bit hard to navigate. So there's another way to find it, which is if you refresh the page, you can see that everything's loaded. Just expand this up a bit so you can see. If you click JS, filter by JS or the scripts, and then if you in the filter type P5, you can see that here is the library. It might take a while for the preview to show because it'll try to prettify it. And then here's the p5.play.js. Cool. So all you can do here is you can actually open this in a new tab or do a save as. So let's do a save as here. So we have this p5.play.js, save, and then p5.js. We'll also do a save. Great. And alternatively, since we are simply saving these files that come from the page itself, you can also try to find the CDN versions of these scripts. And you can find it via like CDN.js, JSDeliver, package, like you can search those areas, but make sure that if you are using a CDN, which stands for Content Delivery Network, that you make sure you load the right versions. Because I know that p5.play currently depends on a lower version of p5.js, which is not the current. And so you want to make sure that the versions match, or else you'll see warnings or errors when loading them both on the page. So cool. And since we're also here, we can also at the same time load our images or save them. And it's using the same strategy as before. You can just click image and you'll see that these are the images that come from the page. And let me just show you real quick. So you can see here, load image, you can see all these PNGs. And pretty much this is the add animation. As you can see that here, it starts at 2 and goes to 7. And so all these images here, you can do the same strategy. You have this opened, and then it doesn't have the save here, so you can simply just do open a new tab, and then right click save as. And you can see that I already have all the images downloaded ahead of time, so you don't have to see me go through a trouble of, right clicking, saving it one by one. So it'll speed things up a bit. Cool. So let me close this up. And now that we have the libs, let's open a Finder. And so the first things first, let us include both the libraries, p5.js and p5.play.js. And simply to load it here, all you have to do is take this and then drag it. Boom. There you go. And you see that they're loaded. You can click on it and you can see that it will show on the right. Nice. And then for the assets, which I have over here, let me do an add folder. Let's call this assets. And then we'll select all these assets, drag it, and make sure it's right underneath the folder, and then drop it. Nice. Click it, you can see that there's an asteroid. So now we have the library as well as the assets on it. What we can do now is, first, we want to load the library. So with this script tag, right before it, we want to make sure that, and let me just close this so it's a little easier to read. So the first script is the p5.js, and the second script is the p5.play.js. And to verify it, and let me just update the title here. And to verify it, we can simply go to this page, do right-click inspect, or using the 3 dots if you're using Chrome, and then going to more developer tools right over here. It's the same thing. And then going to network, you refresh and click all. You'll see that they all loaded successfully. p5.js, p5.play.js. Sweet. So now the first thing we can do is we can go to our script. It's right over here. It's currently blank, so we can do the initial setup. So as you can see here in the code, there's these functions. And you might be wondering, where is this setup function coming from, or this draw function? Or you may have asked earlier, like, where does this load image come from? These are not native DOM functions. These are functions that are exposed by the p5.js and p5.play libraries. and this is being used in the global mode. So what the global mode means is that it injects these functions from the library in the global namespace or in the window namespace. And so you can use it easily without having to use it in some local scope way of doing things. This is good for prototyping, but of course, if you're building a production app, you don't want to pollute your globals. So you want to go for the local mode if you're building something for production. But in this scenario, I'm okay with going for the global mode. And so first things first, like every other p5.js project, we want to have a setup. So setup happens first, and this is used when you want to set up your canvas, for example. So create canvas is a p5.js method, and this is 800 is the width, it's in pixels, and then 600 is the height. And you can simply verify it by going to this page, hitting refresh, and if you do inspect, the canvas should be there. There it is. Look at that. So you know that's working. You can actually add, let's say, draw a background. So draw is another function. Draw happens every X times per second. So you can actually like test what the FPS or the frames per second is, but draw is something that is happening constantly. So normally when you're thinking about a game, you think about certain types of life cycles, right? You first think about setting up things, right? There's also a preload where you preload assets and then you kind of boot your stuff. And then you have like your main life cycle where it's drawing like 1 frame every second or 60 frames every second, actually. That's usually a better frame rate. And the draw is where it's being constantly, where things are constantly happening. So here we'll set a background of 0. What 0 means is it's black, and black is because it's in RGB value, red, green, blue. And so 0 is the darkest, and of course the brightest or white is 255. That's the max integer. So by just doing these two things and you refresh the page, you can see that you have a black canvas. Let me actually make this, let me zoom out a little. Currently I have things zoomed in just to make it easier to see, but now you can see, there we go, a single black canvas. And so first things first, let us load the image. So currently in their example code, they load it in the setup, but we can load it in the preload. So preload should be the function name. If not, I can always Google it and double check. And let me just load the ship. So this is the ship. Cool. So ship image equals nice. And then we can create a variable for the ship image right above there. And so let's go back here. Let's right click inspect. And then let us go to network. And let's refresh. And as you can see here, boom, it is preloaded over here. Awesome stuff. And then now that we have in the preload, we can go into the canvas. So in the canvas, let us draw our ship, or let's create our sprite. So you can see in line 17 in the example code, that's what it's doing. It's creating a sprite and it's setting certain properties to it. For now, we won't set the properties, but we will create the sprite. So let's do var ship so that it's defined beforehand. And then create sprite is a p5.play helper function. So here, width and height are actually global variables exposed by p5.js. And that's simply the width and the height of the canvas. So what's doing here is it's telling it to create a sprite in the middle of the canvas, in the center. And then if I refresh, so I'm gonna close this, refresh this, and it is not drawn. And the reason is because we want to make sure that we draw all our sprites we need to call this command, draw all sprites, in the draw function. Because draw is when all the drawing, or you might think the painting, happens. So if we refresh it here, it should show up. But it is green. So that is interesting. Let me just quickly take a look. Okay, no console errors. Just want to check the sprite again. So the sprite here is correct. But it's interesting how it is coming off as green. So I may have not correctly, let me think, drawn it. So draw sprites is also a global function, or if you use the local mode, a method provided by p5.play. Cool. And the reason why I didn't draw it correctly was, me being a doofus, is that we need to do a ship.addImage. And so, given that we use the create sprite, which came from p5.play, addImage is the method that we need to call in order to make sure that we have a normal image, and then we can give it, so normal is like the key, for example, and then ship image is the image we set it to the sprite. Now it will draw correctly. There we go, nice. So we have our ship. And so let's, add some keyboard controls to it. So adding keyboard controls is pretty simple. As you see, there's the global key down that we can utilize, and the left, right, up arrows, which are once again globals that we can make use of from the libraries. So draw sprites will always happen at the end. So we do a key down and then left arrow. And let's see. Cool, so it seems like left arrow should be a global, but just to be sure, I will console log it to double check. And so if left arrow is pressed, we do a ship.rotation and we subtract 4. So let's try it. Refresh, hit left, and you can see it's rotating on the left. Nice. And so, since I also console logged it, I should be able to see that left arrow is also a global variable. Yes. So pretty much left arrow, right arrow, up arrow, these are all key codes, and they should be exposed by the P5 or the p5.play libraries. So that's a pretty nice thing to use without having to remember whether it's like 32, 37, etc. And then next up, we want to rotate it to the right. So let's do a key down right arrow. So you could actually rewrite this to, instead of 2 if statements, to do an if and an else if. But for now, I will follow the example where they have it separate. Probably it's that, if people are pressing both left and right at the same time, maybe it kind of counteracts each other. But there shouldn't be like a bug from doing it like this. So refreshing this page again. Now if I click the right, boom. Now I can rotate it left and right. Sweet. And then next, which is the cool stuff, is let's add the key down for the up arrow. So now moving it forward. So here, it does 2 things. It adds a speed to the ship. It also includes the ship rotation to ensure that it's moving in the right direction. And then it also changes the animation. And we didn't load the animation yet, so we're not going to use that. And then otherwise, if it does not press up arrow, then it's normal, meaning it changes the animation back. But for now, let's refresh the page and see what happens. So now I can do left, I can do right, and if I press forward, it moves. Nice. And so you might be wondering, so how were we able to make it move in our example, but not the example? So here I can show you the source of the bug from the example itself. The source is actually coming from here, this line, ship.friction. So you see there's two things that it's doing. It's trying to set a max speed so that you don't hold the play and then you like zoom way off the screen because there is no limit. So the max speed is actually super useful, but the friction here is too high, and so the ship is barely moving. So we can go back here, add the max speed, but for friction, we can probably set it like to a really small number. Like for example, let's paste it here. Let's make it like 0.01. So going here, refreshing again, you can see that there's some friction. It's moving. And let me hold it down. You can see that it doesn't go beyond a certain speed. Cool. So since we're here, let's also add the animation, because adding it would make it look pretty cool. It has a nice user feedback to it. So all you do when adding animation is, if I can copy this, let me do it from the start, right over here, copy all the way to the end. Hopefully that helps me copy it. And then, let's see. Oh, it didn't copy the whole thing. That's okay. Copy the rest. Boom. So I can see from this syntax, once again, the first argument is the key thrust. And then the second and the third is the starting image to the ending image. And you can see it actually knows to increment from 2, 3, 4, 5, 6 to 7. And here, if you want to add the animation, we can simply go down. And then we want to change the animation. So we have change animation as the sprite method that we can utilize, change it to thrust. Otherwise, we change the animation back to normal. Boom. So let's take a look. So, ooh, look at that. The thrust is coming, and then when I stopped holding the up, the animation goes back to the normal default. Looking good. So, as you can see, these keys, like they're whatever you want to call it, whatever strings you want to use. So normally a good practice is that you replace it, since it's used in multiple places, and replace it with constants so you can always use them. So let's just create some constants here. Let's call it ship normal. Just call it normal over here. And let's call the second one ship thrust. And then call it thrust here. And so if the animation is changed multiple times, you don't have to worry about accidentally, misspelling the string, for example, and the constant would just throw like an undefined variable if you happen to misspell the variable. So this is like good practice. It's a nice refactor. It keeps your code a bit clean. So finally this one, ship normal. Awesome. And then refresh the page to see that it should still be working without any warnings or errors. Nice. Looking good. And so we have this working. Great. Next step, let's actually, let's fire some bullets. That seems like the next thing that we can do. And after firing the bullets, we can work on adding the asteroids. So as you can see here, if key went down X, then we have the bullet. And so if we go to, let me see, first, of course, we want to load the bullet image. So going back to the preload, we can do like over here, bullet image, load image, and it will be asteroids bullet right over here. Nice. And let's also make sure that we create a variable for bullet image, so it's not undefined. Excellent. And then let us now, so here, a cool thing is they're now using group, and group is a class provided by p5.play. So right after all the ship stuff that's happening here, we do a bullets equals new group. So now this groups all the bullet sprites together, so it's all managed by one. So bullets, let's initialize the variable down here. And then let's going back down to the if key went down is X, you'll see that we call the create sprite to create the bullets, and we also add it to our group. So let me just copy all this over here. So we have our bullet, and see it creates sprite, creates it at the ship.position.x, ship.position.y. So at the x and y coordinate of your ship sprite, that's where it's going to create sprite. This is being a p5.play function. And then we do a bullet.add image. So the sprite will add the image of the bullet image, and then we set the speed. So the speed here is 10 plus ship.getSpeed. So it ensures that, you know, as your ship is moving, your bullet isn't traveling slower than your ship, at least. So it doesn't look like the bullet started behind your ship. And then once again, it follows the right ship rotation angle. Here, bullet.life, what that does is it sets a lifespan of your bullet so that it gets destroyed after a certain amount of time. This ensures that the bullet gets cleaned up and it doesn't persist forever. It's also good for memory management for games. And then bullets.add. So bullets was a new group that we added. And so now it gets added to the bullet group. So if we go back to our page and then we refresh, now if we press the X button, you can see that, there we go. And so if we move the ship and fire, that works as well. And so just to show you what the bullet.life is doing, let me increase the lifespan. Let's double it to 60. So you saw how far the bullet is traveling here. You can see that it goes all the way over here. Let me refresh it again. And you can see now it's going much farther. And so that's what the life is doing. See how far it's going. Double the length. Cool. We'll keep it back to 30, but we can always adjust. Given that you're the game maker or the game designer, you have the authority to adjust all these variables and properties to make it either more fun or more exciting for a player. Sweet. So we have that done, and I think the next thing that we can actually do is we can create our asteroids. So let's do that. So asteroids being our enemy, the goal of the game is to destroy all asteroids without getting hit by them and destroy it ourselves. And this kind of makes it a little bit challenging. That's why asteroids is interesting, because there's a goal and there's an enemy that you want to overcome. And so let us load our asteroids. Cool. So first things first, where is the load image? So load image, it seems like we are only doing load image on the bullet and the ship and the particle image. There is no asteroids in terms of load image. So let me do a command find, and I see it's loading the images here. So whenever this function create asteroids is called, that's when the load image is happening over here. And this is happening where? This is happening in the setup, so that's fine. If it wasn't happening in the setup and it was happening in the draw, I actually would not recommend it because it's slower in performance. And you can definitely optimize it. And so already what we can do here is we can actually preload it since we have a preload function over here, and we can do somewhat the similar thing. So let's go over here, copy this, load image. So we have variable of image. So let me just copy the load image over here. We have our preload. Let's paste it over here. And of course, this won't work. This will throw an error. The reason is because, or actually no, this will work, but it won't load all our asteroids. And there should be in total 3 asteroids, I believe. Is that correct? Well, we can check. So let's check. In our assets, how many asteroids do we have? We have 1, 2, 3. Oh, no, this is the bullet. So we have only 2. Oh, we have 3 asteroids. 0 index. 0, 1, 2. So that is correct. And then we have bullet, we have our ship, and then we have our ship animations. Cool. So this number 8 is just that in the game itself, create 8 asteroids in the beginning. So 8 is just an arbitrary number in the example file itself. So going back over to script.js, let us go to the preload. So we know that there will be 3 asteroids, so let's just load all of them. And that's pretty simple. We can just do a basic for loop. So for loop, we have our starting number, which is I equals 0. And then we have when I is less than 3, meaning it can go up to 0, 1, and 2, we want to do I plus plus, or I increment by 1. So as long as the condition where I is still less than 3, it will continue the loop. So we paste that line over here, and then we don't need to do the random anymore. We can just simply delete this part and then replace it with I. And so we can do load image and it'll be I. And let's actually save these images here. Asteroid images. We'll make this an array. And so what we can do here is we can do asteroid. Let's create a variable just to make the code really easy to understand. Asteroid images, push the image. Cool. And so let's go back to here. We can double check that they are preloaded by inspecting, going back to our network main, and then refreshing. And there we go. Let's see our beautiful asteroids. Nice. They are loaded. So now that we have them loaded, let us do the create asteroid over here. So it is in the game, we will create 8 asteroids based on how this code is written. So let's go to our setup. And then let's paste that. Excellent. And let's also create our asteroids group. Beautiful. So we don't have an undefined variable. So let's just take a look at the code here. We have, so random 360 means give me a random angle. So that's the angle. And then px and py seems like it's just the x and y coordinates. So it's taking the canvas width, dividing by 2, so finding the center, and then it's adding 1,000, so it's out of the canvas bounds. So it creates it outside of the canvas, and then it multiplies by cosine radians angle. I actually do not know what that means, but you know what? I'm curious. So let me just log it just to take a look. So why is it doing something like that? So I just want to log and see what that is. And since we're here, let's also include in the log the px. And then, oh, well, create asteroids won't work right now since we don't have that function created. So for now, I'm going to comment it out. So let me inspect. Open up the console. Let's refresh. We can ignore these warnings. Okay, interesting. So we have, so yeah, this is run 8 times. 1, 2, 3, 4, 5, 6, 7, 8. So the for loop is working. And so the first is the px, and the second is the trigonometric calculation. Okay, so they're all values that are between -1 and 1, it seems like. Gotcha. Well, I still don't know exactly what it's doing, but I think what it's doing is, since it's getting multiplied, is to make the value smaller. Because if it's between -1 and 1, the value of it will always be less than the original value. If it was greater than 1, it would make the value bigger. So I guess it's just to ensure to restrict the boundary size of the game canvas itself. Cool. So let's work on adding the create asteroid. So let's take a look at the function from the example. Create asteroid, right over here. Nice. And so as we can see, the first is a type. The first argument is type, second is the x, and the third is the y. So let me just copy it, and then we can break it down and see what it's doing. So pasting the function here. Awesome. And so here, regarding the image, we don't have to actually do load image anymore. The cool thing about it here is now we can actually, since we have the images preloaded, we can do asteroid images, since that's an array, and we can just do a random of that array. Right? Because we have, if it's random, it should be random of 0. Is 3 inclusive? That's a good question, actually. I didn't think about that. So if I do a random here, so this should be global, so min and max. So if I do 0 and 1, okay. So here it will always be 0. What about 0 and 2? Okay, 0, 2 will always be that. Did I miss something? Oh, I forgot the floor. Okay, so that makes sense. So it will always be between 0 and 3. It will never be the 3 exactly. And so the floor ensures that it takes that number and drops it to the lowest integer. So if it's like 3.14, well, it won't be 3.14, but if it's like 2.7, it'll be a 2. Right? If it's a 2.1, it'll be a 2. And so that's what floor is doing. Technically, I also believe that floor here is the native math.floor function. So you can technically just use that, but for now, we'll just follow the example as it is. We can actually test it just by typing floor and seeing, yes, I think it should reference the native code. Yeah, because you can see, since this is an alias for the native math.floor, but random is its own function from the p5 library. Cool. So let me first refactor some of the stuff here. The A is probably short for asteroid, but let me just write it out so it's a bit more readable in a sense. So another great refactoring tip is that when you're refactoring code, it's always about the importance of maintainability and readability. Most of the time, people are reading, or other people are reading your code. And so if you write your code too cleverly or using too short of abbreviations that nobody understands what it stands for, people be like, oh, what is A and what is B? And so it's a good habit to be explicit on how you name things and name it so that the name itself explains what it's doing. And so it's a better mental model to grasp your and other people's code. Because trust me, if you return to your code like 6 months from now, I bet you'll forget like half the things that you wrote there. That happens to me all the time. So I'm just adding some spacing because I like good spacing. And so let us see what is happening here. So the image part over here seems fine. It makes sense. And then here it's also setting the speed. And it's setting the speed based on the type. So what is type? Let's actually look at the code to understand. So it seems like there are only two types, when it's 2 and it's 1. However, I just want to make sure, since I see that it's doing a loose comparison check instead of a strict. So in JavaScript, you can compare by using double equals or triple equals. I generally prefer to do strict when applicable, and the only reason is because double equals would mean that if you have something like this evaluates to true. But if you do triple equals, you do this evaluates to false. So it's always good to be strict because it also checks your type as well, instead of trying to coerce or typecast. And so I think what it's doing here is it's keeping the state of the asteroid type so that it starts off with a super large asteroid. I think in that case, the type is 3. And then as it gets hit by a bullet or collides with something, it then drops down in type to the point where type will be 0, and then the asteroid will be deleted. And because you can see over here that when type is 2, the asteroid gets scaled down. And then when the type is 1, the asteroid gets scaled down even further. So you can see that how the asteroid is going from larger to smaller. And that is what type is doing here. And so here we have the asteroid.mass. We have a mass over here. We have a set a collider. So here is where the collision detection magic is happening. So set collider is a special p5.play method on the sprite class, and it's pretty much drawing a circle on the asteroid. And these are kind of, once again, the XY position, or actually not, yes, the XY, well, not the XY, but the radius. And yeah, and the radius of the circle. And the asteroids.asteroid, and then it returns a new asteroid sprite. Gotcha. Okay. So let's actually, we can actually draw the asteroid now since we're over here. So let's do that. Let's refresh the page. Let's minimize it for now. We have it minimized. Let's refresh the page. And I'm still console logging something. Let me remove that console log. I don't need it anymore. Then refresh. And the asteroids aren't showing. So why are the asteroids not showing? The asteroids are not showing because, I see, because we need this magical code over here. So the asteroids are now created out of bounds. So by default, it's probably continuing to move out of bounds, and so we are never seeing them. So what this code does is it loops through all the sprites. All sprites, once again, is a function that p5.play provides, and that gives you all the sprites in an array. And then it'll detect that if it's out of the screen or out of the current game canvas, it will then move it back into it to ensure that everything is visible within the game screen. So let me first copy this and then move it to the draw. So let's paste it. I'll do some formatting again. Cool, and it seems like, so if s.position of is less than negative margin, okay, so that's what it means. This is why formatting is also useful. When you see like less than minus, you're like, is that an arrow? What is that? But it's simply just doing a math comparison in essence. Cool. Have it over here as well. And then here we have the Y position is less than negative margin. We want to move the Y position of the sprite to the height plus margin. And then here, when the sprite's Y position is greater than the canvas height plus margin, then we want to move the Y to the negative margin. So is margin a variable? Yes, it is. See, margin is a constant. So this is not provided by p5 or p5.js or p5.play. We want to make sure that we include the constant over here. So going over here, let's actually rename the s over here so that it's more readable. Cool, I'm just doing some copy and replacing. Cool, and it looks good. Yeah, so this ensures that anything that goes out of bounds of the game canvas will then be moved back into the game canvas. But just like in Asteroid's fashion, if you go up, it will move you down to the bottom, so it looks like you're always looping in a sense. So let me refresh, and oh, look at that, asteroids are showing. So if I keep moving forward, you can see how that logic is keeping the ship moving forward. Although I don't know if it's moving in a straight line, but that's okay. That might be a feature. It is moving in a straight line. Cool, nice. So next up is, we want to shoot these asteroids, blow them up, and also get hit and die as well. So let's do that. So we have in total 1, 2, 3, 4, 5, 6, 7, 8 asteroids over here. Let us add the logic where an asteroid collides with the ship and the ship dies. So let us do that. So here we want to do collision detection. And so we have, so currently they have a code here that says ship.bounce. But honestly, we don't want to bounce with the ship. I can show you how it looks like. So let me just copy and paste it. Show you real quick how it looks. This is in the draw. So this happens right after here. And so by doing ship.bounce, this is what's going to happen. It's just going to bounce around. You can also notice how the collision box seems a little big. And let me actually show you why that is the case. So as you saw earlier below, there's this comment out a.debug equals true. That's actually that's kind of useful. So this is actually used on p5.play to debug the sprites themselves. So we can actually do that over here as well. So let me go to the ship sprite over here, and let's set it to true. Actually, what? I wonder if we can just do it straight in the console. Let me do that here now. Equals true. Nice. I don't even need to do it there. And then asteroids. Can I do it for all the asteroids? So this is the group. Is there debug? There is no debug. So I will have to loop through all the asteroids. That's totally cool. Asteroids.forEach. So we have an asteroid sprite for each one, and then asteroid.debug equals true. Nice. So you can see over here that when you enable the property, you now see the collision boxes. It's actually pretty cool. And now as they're hitting, you'll see how the bounce is happening. So if you want to kind of fine tune your game in a sense, like debugging the collision box and how large it is useful, because you don't want a player to be like, oh, this asteroid barely scraped me or touched me, and then die and get them frustrated. So you could like update it such that right now this is a box. You can see that the asteroids have circles. you can see if there's a way to like create a triangle bounding box for your ship. Maybe that could be useful, or just make the rectangle smaller on your ship itself. For now, we'll keep it as it is. I think it's okay. And yeah, this is actually pretty cool. So we will remove the bounds since we won't be using it. What we want to use instead of bounds is we want to use collision. Let's go back here. So you can see how here asteroids have an overlap, and the overlap is with bullets. So we want to actually do here asteroids overlap and with the ship instead. And then we want to do the asteroid hit function. So let's take a look at the asteroid hit and see what it's doing over here. So here we have this function. Currently it's being hit is with the bullet. We'll instead replace the bullet with the ship. And then we will try to analyze and see how to update the code so that when ship hits asteroid, ship also dies. So I will rename all the bullets here actually to sprite, since in the next or in the future we actually want to do collision detection for both the ship as well as the bullet. So 2 types of sprites. Okay. And so let's try to understand what this code is doing. So when asteroid sprite collides with ship sprite in our case, but in the future case, ship or bullet sprite. So here is where it's keeping the state of the asteroid type. So it's subtracting 1 from the type. If the type is greater than 0, it wants to create a new asteroid type with the type -1 at the asteroid center, X and Y. And so it creates 2 asteroids, I see, at the center, and with the smaller type. So as you can see, a large asteroid gets hit by a ship, the big asteroid gets destroyed, 2 new smaller asteroids gets created, and then what is happening over here? So here, it seems like we have a for loop. 10 things are generated in the for loop, and what is happening? It's doing create sprite, sprite.position X, sprite.position Y, so that's the center of currently the ship, and then it's doing particles. Okay, so now it tries to create a particle effect or explosion effect. So for now, actually, let me comment out this particle effect, because we can add it later. I'll still need to preload the particle images. And here we have sprite.remove, asteroid.remove. So at the end of this, with the asteroid hit function, the sprite or the ship gets removed, and the asteroid also gets removed. And so if I refresh, let me just collide with one of them, and boom. Oh, the asteroid died as well. Interesting. Okay, so you know what? For now, let me actually add the debug on all these guys, just in case. So we have asteroid.debug equals true. And then let us have a bullet.debug equals true. And then let's also add a ship.debug equals true. The ship is created in the setup. There we go. Ship.debug equals true. But as you can see, the ship did die, but then the smaller asteroids that were created got removed as well. So let's see what happened there. So when you collide, oh, it seemed like as if the ship continued to exist, even though it got removed. And so what we need to also actually make sure is that in the asteroid hit function, if the sprite, I think if the sprite is removed, so let me just check it over here. We have our ship. Let's see if there's a removed property. It's true. If it's true, then don't do anything. So sprite.removed, just return. Early return over here. I think that would make it better. Refreshing the page. Let's collide with this asteroid. Nice. So, because the ship got removed, what was happening was that even though it was removed from the screen, it was still present on the game itself. It wasn't completely destroyed. And so we want to make sure that even the completely not destroyed ship, even though removed, was not causing additional collision of detection with the asteroid sprite. And so let's now add the particle effect. So I think this would add a little pizzazz to the game itself. And so let us look at where the particle images are being loaded. So right over here, just a single load image, particle image. Perfect. Let's go into the top of the page to the preload function. Let us add it. Boom. Particle image, load image. And let's create particle image. So we define the particle image, and now it's being loaded over here. Excellent. And then I believe that's it. Once we load the image, we can use it. So going back down to the asteroid hit function, we can now uncomment this code. So this creates 0 to 10 or 10 particle images. Let me just rename the p variable just so it's a little more intuitive what it is. Particle, there we go. So we create a sprite particle, center of the collided sprite, the ship, add the image, we set the speed. This friction once again will make it not move. So let's just make it 0.01 again, and then the lifespan. So that's the time that the particle will show up on the screen. And that's 15. So it's a short duration, shorter than even the bullets. So let's do it now. Let us collide with one of them, our closest neighbor, asteroid. Boom, look at that. That seems pretty nice actually. And so we have the asteroid killing the player or the ship. So the next thing is we want to have the ability to kill the asteroid. And so we want to now add a collision detection for the bullet. Same thing with something like this. So all we have to do here is actually pretty simple. We go back to the draw function right over here. So we have asteroids overlap ship. Now let's do an asteroids overlap bullets. So this is the bullets group. So the groups contain all the bullet sprites. And if we do this correctly, let me refresh. I can actually start killing all these. Nice. I can start killing all these asteroids. Nice. And I can move around. Okay, I lost myself there. Cool. I need to train my game instincts. It's the reason why I'm not a gamer. And yeah, that's it. We can add the helpful text. So you can see one last thing over here. Fill with the text align center. So let me add it below. And the reason is because in terms of the layering of what gets drawn, as you can see, whatever comes first gets drawn first. So this could sometimes lead to like the asteroids showing up in front of. This is actually just text telling the user instructions of how to play the game. It's just a placeholder text. So I will actually copy this to the bottom. So at the bottom, right below draw sprites, I will do this. And so fill, text align, these are all p5.js methods. So fill 255, as you can guess, will fill the text color to white. It will center it to the center of the screen. And then it will pretty much say what the controls are. So here, as you can tell, this is the X position, center of the game canvas. And then we're just adding a bit of margin from the top of the screen, just 20 pixels. So if we refresh, you can see now we have our text on the top right over here. And one improvement that you can probably do is you can add some stroke to the text. By adding the stroke, like if the white canvas, the white asteroid goes over it, like you can at least still read the text in a sense. But that's pretty much the gist of it. I think we've accomplished a lot in this very short tutorial on it. Things that you can do as a to-do to improve is, of course, adding stroke to the text, making the collision detection boxes better, like maybe making the circle smaller and the rectangle on the ship smaller. And then you can adjust with the size and the speed and the properties of the sprites themselves, like making the ship faster, slower, the lifespan of the bullets longer. And of course, you can add some title screens. Like when it's a game over, you can do a restart, or you can add even lives to it. But I think we've accomplished a lot in this short live stream, and I'm excited to see what you will build next. This repl.it, of course, is public, so I will make sure to add a link to it in the description after I end the stream. But other than that, I'm glad that you enjoyed this, and I will be ending my stream. So thank you, everyone. And I'll see you in the next Remarkable Mark live stream.